Welcome to Lesson 5 of Module 3, Nonlinear Functions. I want to start this lesson by showing you this image and asking you, what do you notice and what do you wonder? Well, you might notice that this is a functional machine, right? It's a vending machine. Us as humans, we love functional machines, right? And just like functions in math, functional machines in real life have inputs and outputs, right? If we take a look at this vending machine, if we input money, our output will be whatever we choose from the vending machine. So I want you to keep that in mind as we work with nonlinear functions. I want you to think about how we're going to put something into the function to then get something out of it. So nonlinear functions, these are any functions that do not form a straight line when graphed. So some common types of nonlinear functions are quadratics, cubics, exponentials, square roots, and absolute value functions. Pause this video and ask yourself, how are these two the same but different? So hopefully you're thinking that they're basically the same question, but the notation is slightly different. So if you take a look at the first one, it says evaluate 3x squared plus 2x plus 1 for x equals 4. What does that mean? That means we're just going to substitute 4 for x and evaluate the expression, right? So if you do that, you should end up with 57. The second question says let f of x equal 3x squared plus 2x plus 1. Find f of 4. So what does that mean? To find f of 4 means to evaluate the function for x equals 4, right? It's the same exact question, just using a different notation. So when we evaluate f of 4 and substitute 4 for x, we also get 57. So in the second one, we're using what's called function notation, and that's what we're going to be using in this lesson. Please pause this video and work on the Lesson 5 Level 1 questions in the workbook. In Level 2, we're going to talk about composite functions. So a composite function is when you're combining two functions together. The notation is in function notation, but it looks a little different, right? It's this fog of x, but it's read as f of g of x. And there are two ways that you'll see this notation for composite functions. You'll see it this way with the fog, right? Or you'll see it the second way, but they're both read as f of g of x, and they both mean the same thing. So in order to evaluate composite functions in this form, first you evaluate g of x, and then use the result in f of x. So we'll take a look at a few examples. Evaluate f of g of 1 for f of x equals x squared and g of x equals 2x plus 1. So first let's evaluate g of 1. Substituting 1 into g of x, we get a result of 3. So now what we're going to do is we're going to take 3 and we're going to find f of 3. F of x is x squared, so when we substitute 3 for x, 3 squared is 9. So f of g of 1 is 9, right? So all we did is we found g of 1 first, and we took that result, which was 3, and substituted into f of x. Now let's take a look at a graph. We have our two functions, f of x and g of x here. We want to know what is the value of f of g of 0. So first we need to find g of 0. G of 0 is 1. So if you look at the graph, g of x is this blue line. If we go to 0, the value of g at 0 is 1. So g of 0 is 1. So now we need to find f of 1. F of 1 is 4. So f of g of 0 equals f of 1, which is 4. Please pause this video and work on the Lesson 5 Level 2 problems in the workbook. So in Level 3, we're still going to be working with composite functions, but now they get a little more complex and become a little more multi-step. So let's take a look at this problem here. If f of x equals 2x and g of x equals x plus 3, what is the value of f of 2 plus g of 4? So what should we do first? First, we're going to find g of 4 by substituting 4 into g of x. So when we do that, we get g of 4 equals 7. Now we're just going to add 2 to what we got for g of 4. So 2 plus g of 4 equals 2 plus 7, which is 9. So now we're just going to find f of 9. We're going to substitute 9 in for f of x. So f of 2 plus g of 4 equals f of 9, which is 2 times 9, which is 18. Let's take a look at this one now. This one is a little bit different, right? They're not asking us to evaluate something. Our answer is going to be an equation. If f of x equals 2x plus 1 and g of x equals x squared minus 3, what is the value of f of g of x? So what should we do here? They're not asking us to evaluate at any given x value, right? So what we have to do here is we have to substitute what we have for g of x, right? The expression that we have for g of x, x squared minus 3. We're going to substitute that for x into f of x, right? So basically, we're going to find f of x squared minus 3. So when we substitute x squared minus 3 in for x, we get 2 times the difference of x squared and 3 plus 1. Now we're just going to continue to simplify until we can't anymore. So we'll use the distributive property and distribute the 2 to x squared and negative 3. And we get 2x squared minus 6 plus 1. Now we're just going to combine like terms, our negative 6 and our positive 1. And we get 2x squared minus 5. Right, so notice how this one is different. They wanted us to substitute the whole expression for x into f of x and then simplify, right? So when you have a question about composite functions and it doesn't involve an actual value for x, don't get scared. Your answer is just going to contain a variable now. It's still the same process. You're still substituting in for f of x. Please pause this video and work on the Lesson 5 Level 3 problems in the workbook. When you're finished with the problems in the workbook, please stop this video and move on to the next one for Lesson 6.